Hello, everybody. Welcome back to another video. In this video, we're going to be taking a look at another question, which is from topic 1. And in this question, they've asked us, solid copper 2 chloride absorbs moisture from the atmosphere to form a hydrate of the formula CuCl2 dot XH2O. Now, we have this question, and I haven't mentioned this, but as you can probably see, the question is is from an HL paper, but it shares content with SL. Both SL and HL students need to know how to solve such questions, and it's from the November 2019 batch. So this solid copper 2 chloride, it basically absorbs water, which in this has been told as moisture, from the atmosphere, and it forms a hydrate of this formula. And this X over here basically denotes the molar ratio of water to CuCl2 in the hydrate of copper 2 chloride. And the X is what we have to determine. And a student has took the sample of hydrated copper 2 chloride, and they have heated it. And when they heated it, what basically happens is that the water evaporates, obviously, right? We knew that water evaporates when we heat it. And the resulting substance that is left is called anhydrous copper 2 chloride. Anhydrous is the opposite of hydrous, as you can probably tell. And it's usually powdery because all the water has evaporated. There's no water left. That's why it's called anhydrous. And we've been given some experimental data over here. We've been told the mass of the crucible. We've been given the initial mass of crucible and hydrated copper 2 chloride, and the final mass of the crucible and the anhydrous copper 2 chloride. Now, the first thing I want us to do is that I want us to find out the exact mass of the hydrated copper 2 chloride and the exact mass of the anhydrous copper 2 chloride. And well, we can do that by, we just have to remove the mass of the crucible. So for hydrated, oops, for hydrated CuCl2, we can find out the mass by just subtracting the mass of the crucible and hydrated copper 2 chloride minus the mass of just the crucible. So it's 18.360 minus 16.221. And that gives us an answer of 2.139 grams. So this is how many grams of hydrated copper 2 chloride that we have. Now I want to find out the mass of the anhydrous copper 2 chloride as well. And it's the exact same method. I just have to subtract the mass of the crucible and anhydrous copper 2 chloride, which is 17.971 as given to us, and I have to subtract it from the mass of the crucible, which is 16.221. So that gives me an answer of 1.75, if I'm not wrong, 1.75 grams. So if we want to find out the value of X, on top we were shown X, right? If we want to find out the value of X, what we need to do is find out first how much water exactly existed in this hydrous copper 2 chloride, right? And also I just want to make a quick correction over here. I made a mistake. It's actually it's 17.917, not 71. And it actually gives us an answer of 1.696. My apologies for that. Anyways, like I was saying, we need to first find out how much water did the hydrated copper 2 chloride contain. And in order to find out how much water it contained, again, I'm pretty sure you've guessed it, we have to subtract the initial mass of the hydrated copper 2 chloride by the final mass of the anhydrated copper 2 chloride. And we get the mass that has been lost as a result of heating it because the water has evaporated. The mass that is lost is the mass of the water that has evaporated. So that would give us an answer of 0.443 grams of mass. And that is how much water has evaporated. Now that we have found out the mass of the water that is evaporated, we can actually find out the number of moles of water that were in the hydrated copper 2 chloride. And we know how to calculate moles. We know the formula for moles. It is N is equal to M over M. Now, M, the small m over here, is mass in grams. We know what that is. And the big M is the molar mass. And we also know what the molar mass for water is. So the mass in small grams is 0.443, and the molar mass of water is approximately 18. So when we do the calculation on our calculators, we get the answer as 0.02461. So these many moles of water are present in the hydrated copper 2 chloride. Now, what do we do with this information? If you have watched my previous videos where I talk about, where I talk about um, how to calculate the empirical formula of a substance, we have to apply the very same logic over here. In order to find out this X, we need to find out the ratio of the number of moles of water to the number of moles of copper to chloride, copper to chloride. And if you want to find out the ratio of the number of moles, we need to, one, know the moles of water, and two, we need to also know the number of moles of copper to chloride. And in order to find out the number of moles of copper 2 chloride, it's the exact same procedure. I'm just going to erase this to make some more space over here. If we want to find out number of moles of copper 2 chloride, we have to use the exact same formula. N is equal to small m, which is in grams, over big M. And we know what small m is. We know that we have 1.696 grams of copper 2 chloride. So it's 1.696 divided by the molar mass of copper 2 chloride, which you can calculate using your data booklet on a calculator. The mass, the molar mass of copper 2 chloride is, give me a second, let me just calculate it, is 134.45. So it's 134.45. And this gives us the answer of the number of moles of copper 2 chloride as 0.01261. Now that we found out the number of moles of both CuCl2, copper 2 chloride, and H2O, we need to see what is their ratio to each other in order to determine X. We can clearly see that H2O is in a larger quantity in terms of moles than copper 2 chloride, right? We have 0.02461 moles of H2O, whereas we only have 0.01261 moles of copper chloride. So to find out the ratio, we need to divide the number of moles of H2O by the number of moles of copper 2 chloride, because that's how we find ratios, right? In order to determine how much of one substance makes up the other, or how, or the mathematical relation between both of them. So we need to divide 0.02461 by 0.01261. And if you've seen my earlier videos on empirical formula, we do the exact same step in the last procedure while determining the empirical formula, where we divide all the number of moles of the substances by the substance which has the lowest number of moles. If you have seen that video, I would highly recommend you to go and see it if you have not. But if you have, then you know what I'm talking about. And this would give us an answer of 1.95. And that is what X is. X is equal to 1.95. But we can't leave it at 1.95 because you can't have a decimal for the number of moles of H2O, or the molar ratio. That doesn't make any sense. So we round it up. 1.95 is really close to 2. So we can round it to 2. So X is equal to 2. That is it. That is all we had to do for this question. The first time I got this question in the exam, I got it wrong. And since then, I've learned this method on how to do it. And hopefully, I've been able to teach it to you successfully. Thank you so much for watching this video. If you have any other questions regarding this concept or any other concept, please feel free to let me know. I believe I've covered a lot in the topic of moles. And from next video, I will start to post different topics. But thank you so much for watching. As always, take care, and I'll see you in another video with another question.